Everyone, ito si Dr. Esperanza at welcome sa aking YouTube channel. And for today, we're going to be working on some calculus lessons at tuturuan ko kayo kung paano gamitin ang derivative ng isang function at bakit tayo kumukuha ng derivative ng isang function. At ito ang isa sa mga topics na kailangan nyo matutunan bago kayo makapag-compute ng mga derivative ng mga functions gamit ang iba't ibang derivative rules. So do stick around at tuturuan ko kayo kung ano ang derivatives, paano gumamit ang derivatives, at bakit kailangan nyong kunin ang derivative ng isang function. Given now that you have this function and this formula, you're able to produce any of the tangent line in this f of x. But that is only limited to just that function. So if you are given or and you're asked to find the tangent line of a certain function on this given point, you're going to be using that formula over and over and over again, because this is the formula that will help you find your slope equation on a given function. Now, in mathematics, it's all about symbols. This is the symbol that we use for the equation of the slope of a line. In this case, we read it as f prime of x. So whenever you see f prime of x, it means you're looking for the equation of the slope of your function in that particular f of x. And another term or description that we use for f prime of x, this is the derivative. The derivative of the function f of x. And in symbol form, to find f prime of x, we sometimes write it like this. F prime of x is equal to the derivative of f of x. So this is just to make sure that you are understanding or you're speaking the same language as mine. Because again, mathematics is a foreign language. You need to know how to read it, you need to know how to say it, and you need to know how to write it. Okay, now, what if we're going to find the derivative of f of x? And the f of x that we have right now is a degree 5 polynomial, 3x to the 5th. So if we're going to find the derivative of f of x, that means we're going to find f prime of x, right? Which is the derivative of 3x to the 5th. And just like how we solved our parabola a while ago, we will be needing this to find the derivative, or f prime of x, of this f of x. Now, what is the problem with this formula?
It's really long.
It's very long. It's very tedious. And it takes a while to solve it. That is why, if we're going to find f prime of x of f of x, we're going to be using this. It would take us probably 10 minutes to work out this problem, just like what happened a while ago. But we're not going to do that formula, and we're going to be using a set of derivative rules so that we can find the f prime of x of a given function a lot faster. This one right here that we're going to be differentiating or finding its derivative will now be found without using that. I'm not going to use that. I'm going to use this, the power rule. And the power rule applies to any polynomial that is looking like this. Any polynomial x to the n, its derivative can be found using this rule. What you need to do is to bring down the exponent and subtract 1 from the exponent, and you will find your f prime of x. So if that's the work that we need to do to find the f prime of x of f of x, therefore f prime of x is equal to the derivative of 3x to the 5th. And what is the derivative of 3x to the 5th? We're going to use this formula. And the formula is bring down 5 and subtract 1 from your exponent. So your derivative function is now what? What's f prime of x now?
15x squared, or 4 to the 4th.
15x
To the 4th.
to the 4th. And that is now the formula that will help you find the slope of any of your tangent line in your f of x. This is our derivative rule. So, going back to this problem, we already know the answer to this problem, right? Can you please use the new rule, new derivative rule, without using the formula, the limit formula, to solve this problem? We need to find the slope, right? How do you find the slope this time? We need to find f prime of x. And what is f prime of x given f of x is equal to 2x squared minus 2x minus 4 using the derivative rule that we've just learned? Now it's 4x minus 2 because you bring down 2, subtract 1 from it, and then this one is just going to be 2. Now we have f prime of x. We can find the slope because, the tangent line, because we know that f of 2 is equal to 0. And now f prime of 2 is equal to slope at x equal to 2 and your point. And now you can write the equation of the tangent line easily. So that is the reason why you're finding the derivative of a function. Now, this is not the only reason why you're finding the derivative of a function. This is one of the many reasons why you need the derivative. So, do you understand now why we're working on the derivative function? Okay. So, if we have these f of x, can you now find the f prime of x of each one of them? And if you need more examples on how to find the derivative of a given function, just click on this I button right here in the corner and it'll give you more examples and more videos on how to find the derivative of f of x given different rules of your derivative function. What is the ddx of 7x to the 5th?
35x to the 4th.
ddx of 3x to the 4th.
12x to the 3rd.
ddx of x cubed. ddx of 10x squared.
20x.
ddx of 8.
0.
0. So the derivative of any constant is equal to 0, and that is another rule that you need to remember in calculus. Any derivative of a constant is equal to 0. So in this case, this will be the derivative of our function. Now, number 2, derivative of 5e to the x plus 3 to the x. Now, some of you are probably having trouble with the first one because finding the derivative of 5e to the x will require you to know the derivative of e to the x. And this is the derivative rule for e to the x. It's just e to the x. So that is the derivative of any e to the x. So of 5e to the x can be written as 5 ddx of e to the x. That's why, what is the derivative of e to the x? That's why it's still 5e to the x. Because in the derivative rule, you can isolate the constant and just take the derivative of the function. And that's what we do, or we did on 5e to the x. We separated the constant and the function. Constant and the function, and took the derivative of the function. So what is the derivative of 3x? 3. So this is going to give us this. Now, number 3, we have the 5th root of x squared. And we're going to find its derivative using the power rule. Now the problem with this function is that it's in radical form. And from the word itself, power rule, you use that when you have an exponent. You have an exponent here, but you also have a root right here. So when this happens, every time you are finding the derivative of a radical, we call this a radical, you need to use your law of exponents. You need to modify your function using algebra. So before you can use your calculus rule, you need to do a little bit of algebra rule first. So, do you still remember your law of exponents? Do you even know what the law of exponents look like? It looks like this. Alright, this is the law of exponent. These are the rules on exponential functions that you need to remember. Specifically,
Fractional exponent.
you need to convert all your radicals into a fractional exponent. And this is the rule for your fractional exponent. Your root will be your denominator and your exponent will be your numerator. It's been a long day. Alright, so let's take the derivative of this function. F of x is equal to x to the 1/2, right? And to find f prime of x, we'll take the derivative of x to the 1/2. And the derivative of x to the 1/2, we bring down 1/2. And we subtract 1 from the exponent, right? So it's minus 2 all over 2 and not the other way around. So we'll have 1/2 x to the, what's 1/2 minus 2 all over 2? Negative 1/2. So this is now your f prime of x. Can we change it back to the radical form? So we'll have 1/2 times 1 all over x to the 1/2, right? And what is x to the 1/2 in radical form?
X squared. Or
1 over square root of x, right? Are we finished with our work? No. What else do we need to do to solve the problem for number 2? Plug in the value of 2. So we have f prime of 2 is equal to 1 all over 2 square root of 2. And what is square root of 2? That is the square root of 2. Because square root of 2 is a prime number. Unless you want to use your calculator. Your f of x and your f prime of x. So this will turn into, I'll change it into rational exponent. 1 all over x raised to 3 over 2, right? And then this will turn into x to the negative 3 all over 2, right? F prime of x is equal to negative 3 all over 2, x to the negative 3 all over 2 minus 2 all over 2, right? And then this will turn into negative 3 all over 2, x to the, what's negative 3 all over 2 minus 2 all over 2? Right? And then we will change it into its radical form. Negative 3 all over 2 times 1 all over x to the positive 5 all over 2. And then we will further simplify this. And this will look like negative 3 all over 2 square root of x to the 5th. This is your f of x prime. Are we finished?
No.
No. We need to find f prime of 1. So let's complete our work. F prime of 1 is negative 3 all over 2 square root of 1 to the 5th, which is equal to negative 3 all over 2. So be careful with how you convert your radicals and how you add or subtract fractions. And again, I always make a mistake because I cut corners. I do shortcuts. I usually do some of the steps in my head and it end up me making a little error in my steps. So my advice, do every little step in your work until such time that you have mastered the rule and mastered your algebra and your calculus, and you'll be able to answer this better. Now, last skill for today. Let's have a recap. 1. You're able to write the equation of the tangent line given a point using the definition of the derivative, the long method. 2. You're able to learn that there is a shortcut on how to find the derivative without using the derivative, the definition of the derivative or the limit formula for the derivative. 3. You're able to use the power rule using an easy function and a function that you need to convert using the law of exponents, right? Last skill for today before we part ways. We're gonna cheat. Of course. Do you wanna cheat? Alright. All AP Calculus students need to know how to use your calculator to solve for the tangent line as quickly as possible. And if you think solving for the tangent line using the derivative rules is quick, your calculator is quicker. So, let's have an example. The example that we used a while ago, like this one right here. Remember this example? It took us a while, right? When we used this formula, and then we're able to produce it or answer it easily and quicker using the derivative rules. Now, how are we going to use the calculator so that we can find the equation of a line a lot easier in any given function? I'm going to write the function first. That's all you need. And now for the calculator. Okay, I'm excited. Best practice, always reset your calculator. Second plus 712. Alright, so step 1, defining the function in your calculator. Have it in your function now? Now, if we use the table values, second function, graph, it will give us all the values of y at x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, right? How am I going to get rid of this so that I can plug in the values of x on my own? Second table set. And I will change it into ask. Alright? Now, for every given value of x, I'll be able to find the value of y using my calculator, right? So, at f of 2, what is the value of y? 0. So that means we have a point on the function which is 2, 0. We just need to find the derivative, right? Right? At x equal to 2. So how are we going to find the slope at x equal to 2? We need to find f prime of 2, right? Ready? This is how or why your calculator is powerful. Go to y equals. On the second y, we're going to tell the calculator to find the derivative of the function at any given point. This is how. Push math 8. Do you have this in your calculator? Now we're going to tell the calculator to find the derivative of any x value in your f of x. How are we going to do that? d dx. The function right here is y sub 1. How do we call y sub 1 so that the calculator will be able to recognize it? Pay attention. This is a skill that you need to learn. To call y sub 1 so that y sub 1 will go here in this blinking square right here. Push bars. Go to y bars and go to function. And you'll have y1 up until y whatever. But what do we need? Do we need y1, y2, y3, y4? Which one do we need?
y1.
So push 1. And now you have y1 in your function at y sub 2. Now for the last part, x, since I'm not looking for just a single value of x, I'll use any values of x, so I'll put x right here, x equal to x, which means you will assign your own values of x. And enter. That is your derivative function. So, Second function, graph. What do you see?
6.
And do you remember that 6 in our classwork a while ago?
Yeah.
That's f prime of 2. And that's how you use your calculator to solve for the derivative of your f of x at any given values of x. Got it? So going back, look at this. See this? See this and this? Your calculator did that for you. Can you please find the tangent line of this f of x at x equal to 3? Your x, your y, and your m can be in decimal form. Okay, do that. The calculator will only work for you if you know how to use it. And there's a technique on how you don't get confused. Whenever I use my calculator, I always need to write what I need from my calculator. And this is what I need from my calculator. I need this in my calculator because this will give me my x and y, right? And I need my f prime of 3 so I can have my m, right? So this is how I use my calculator. I always write what I need. And then I'll go to my calculator to produce what I need. And to do that, so that I can plug the value of n. What do I need? X equal to?
3.
So this is my y sub 1, 0.045. And my f prime of 3, negative 0.036. In calculus, in AP calculus, you need to round up your answer at the nearest thousands, 3 decimal places. And now that you have all of these, now you can write your equation, right? So my equation would be y minus y1 equals m times x minus x1. So I'll have y. What's my y? Minus 0.045 equals, what's my m? Negative 0.036, comma, parentheses, x minus 3. And you're done. That is your equation of your tangent line. So, at any given function, it may be a cosine function, it may be a logarithmic function, it may be a tangent function, you will be able to solve for the tangent line because now you know how to use your calculator. Because in the AP Calculus test, there are 2 parts of the test, the calculator part and the non-calculator part. All AP Calculus students should know how to do calculus by hand, calculus using the calculator. And again, ito po ulit si Dr. Esperanza at thank you for watching my lesson on derivatives. At kung nagustuhan nyo yung video na napanood nyo, please like, share, and subscribe to my channel. And please subscribe to my second channel as well para mas dumami kayong mga students na matutulungan ko. See you again next time sa aking workshop dito sa Barstow Community College. Bye! This is a video. So this is our last minute here in Chapman and we're going home back to Barstow.